topic that we're going to tackle today is stoichiometry. It is a method that we will use. Hey, sorry. Yeah, it's okay. I'll edit it out. Stoichiometry is a method that is going to utilize a balanced equation to determine the quantity or quantities of a reaction component. So we're looking at mass relationships here and the way that reactant mass and product mass are related to one another. Because atoms must be conserved during a chemical process, during a chemical reaction, we only need one quantity. Only one quantity is necessary to determine any other quantity in the reaction. And so the best way to do this, you guys, is let's just get started with this thing and see what I'm talking about. So our question is, what mass of oxygen will react with 96.1 grams of propane? Well, the first thing we're going to need to be able to solve this problem is a balanced equation. So, propane and oxygen are going to react with one another, and they're going to form a couple of products. And so we need to write an equation and balance it in order to know how our different quantities are related to one another. So we've got some propane here. You should be able to write the formula for propane. So we've got C3H8, and that's a gas, and that's going to react with some oxygen to produce, and whenever we have combustion, that's oxygen. Okay, so things reacting with oxygen. Whenever we have the combustion of a hydrocarbon, we always get the same two products. And those products are carbon dioxide plus water. Always, those are the products. Okay. So let's see. We've got 3 carbons, and we have only 1 carbon here in our products. So that means that this equation is not balanced because we have to account for all of the atoms that are going into this reaction, products. So I'll put a 3 here. So that's 3 carbons, 3 carbons. Now, because I can end up balancing the oxygens in the end, I'm going to leave these 6 oxygens alone for right now, and I'm going to move on to the hydrogen. Okay, I've got 2 hydrogens, I've got 8, so I'm going to multiply this by 4. So now I've got 3 carbons on both sides, I've got 8 hydrogens on both sides. Let's balance out the oxygens. So I've got 6, and I've got 4, which is a total of 10. So that means I'm going to put a 5. So, in the real world, what is actually occurring in this chemical reaction is that 1 molecule of propane is reacting with 5 molecules of oxygen gas to produce 3 molecules of carbon dioxide and 4 molecules of water. That's how the thing really happens. But we don't utilize molecules because we can't weigh them. They're so small. I mean, we can, but they're so small that we need to talk about very large quantities of these things. So that means that 1 mole, it's much easier for us to think of it this way, 1 mole of propane reacting with 5 moles of oxygen produce 3 moles of carbon dioxide and 4 moles of water. So from this, we can now address this thing right here. How much, what mass of oxygen will react with 96.1 grams of propane? We have our balanced equation. And now we're just going to go through the, oh, I don't want that. Let's begin with what we're given. We are given 96.1 grams of propane. 96.1 grams we always begin with what we're given, which is 96.1, in this case, 96.1 grams of propane. And we're going to put that over 1. And that's how we're always going to begin. C3H8. And we're going to put it over 1. Okay. From the balanced equation, we're relating numbers of particles, numbers of molecules, moles of molecules with one another. We are not relating grams of these things in this balanced equation. We're relating pieces. And so our grams, this isn't 1 gram of propane reacting with 5 grams of oxygen, giving us 3 grams of carbon dioxide and 4 grams of water. That's not what those numbers represent. They represent numbers of pieces of these things. And so our first step here is to convert grams to moles, because then we can relate one thing to another in the balanced equation. So we're going to use the molar mass of propane to convert grams of propane to moles of propane. So the molar mass of propane is 44.1 grams of C3H8 per mole of C3H8. Sometimes problems will begin with the number of moles of the thing. And if it begins with the number of moles of the thing, you don't even need to do a molar mass conversion. You just go straight, you just put the number of moles over 1. Okay. I'm going to cancel my grams of propane. I'm done with that. I'm trying to get to grams of oxygen. Okay, the only way that I can relate propane and oxygen is via the coefficients in the balanced equation, because that tells me how many pieces are reacting with each other. So now I'm going to introduce you to a very important piece of this puzzle, and that is called the mole ratio. And the mole ratio is the heart of the stoichiometry problem. And what that means is, what is the ratio between the moles of the two substances that we're comparing here? And we're going to find that in our balanced equation. So, the moles of my known is going to go in the denominator, and the moles of my unknown, O2, is going to go in the numerator. And that's easy for me to do and to see, because these moles of propane will cancel with these moles of propane. So there's no shortcuts. There's no leaving out the chemical formulas in a stoichiometric dimensional analysis. You need them in order to know that you are solving for the correct quantity. So I'm going to go to my balanced equation, and it tells me that for every 1 mole of propane, I'm going to use 5 moles of oxygen. So these are the coefficients from the balanced equation. They describe the relationship between the number of pieces that are reacting. So now, with the heart of my stoichiometry problem in place, I can cancel my moles of propane. So now, suddenly, I've converted to moles of O2 via my mole ratio. But I'm not looking for moles of O2 in this problem. I am looking for mass of oxygen. So how am I going to go from moles of oxygen to mass of oxygen? I'm going to use molar mass. So that means that 16 plus 16 is 32. So oxygen is 32.0 grams of O2 per mole of O2. This is going to be 32.00. Is this 44.10? I want you to take it to the hundredths. All right, my moles of O2 are going to cancel. And now I can total this thing up on my calculator, 96.1 divided by 44.1 times 5 times 32, and that is going to give me the mass of oxygen that will react with 96.1 grams of propane. And so what does my answer come out to be? Do I have an answer anywhere? I don't. So you're going to need to calculate that, and I will calculate that, and we will look at that on Tuesday. Okay, let's do another problem. How many grams of propane are needed to produce 21.5 grams of carbon dioxide? Okay, so again, C3H8 reacts. It's going to react with 5O2 to give me 3 carbon dioxides, 3 moles of carbon dioxide, and 4 moles of water. Did I say 3 grams? I meant 3 moles. Plus 4 moles of water. Okay, so like we said at the very beginning of this thing, you really only need one quantity to determine any other quantity in the reaction. So that means that it doesn't matter if you are given the mass of a product, you can figure out the mass of either of the reactants that produced it, or given the mass of either one of the reactants, you can figure out the mass of either of the products that are formed. You can be given the mass of this product and figure out the mass of this product that will form as well. So you only need one quantity, and it doesn't matter whether that is a product quantity or a reactant quantity. One quantity is all it takes to be able to figure out any of the other quantities that are in the reaction. Okay, so what are we given to start with here? 21.5 grams of carbon dioxide. So we're going to put that over 1. So it's 21.5 grams of CO2, and it's incredibly important that you write the units. Okay, and again, you know, it's the mole ratio that's taking us here, and that's why we can relate any of these quantities to one another, because we've got all of the mole ratios. This thing reacts in a very well-defined way that does not change. So, we're going to convert grams of carbon dioxide to moles of carbon dioxide because it's pieces that this thing is reflecting. So, carbon dioxide, 16, let's see, we've got 32.00 plus 12.01, 1044. Okay, so carbon dioxide is 44.01 grams of CO2 per mole of CO2. And we can cancel. What comes next? It's the heart of our stoichiometry problem. It's what is going to take us from moles of carbon dioxide to the moles of our unknown. And so we're always going to put our known in the denominator, moles of CO2, our unknown in the numerator, moles of C3H8, that's what we're looking for, propane. And then we're going to go to our balanced equation to figure out what the actual numerical ratio is. And that means that for every 1 propane, how many CO2s do we make? We make 3. Great. We're almost there. We're at moles propane now. And if the question said how many moles of propane are needed, we'd be done with the problem. But it's not. It's asking us for grams of propane, so we're going to need to convert it. So we actually have the molar mass of this somewhere else, right? It is, oh, very close to the CO2. So we've got 44.10 grams of C3H8 per mole of C3H8. Moles of C3H8, propane cancel. So we will say 21.5 divided by 44.01 divided by 3 times 44.10, and that will give us the grams of propane that are needed to produce 21.5 grams of carbon dioxide. You will see lots of flowery language in problems. And what you have to keep in mind, do not panic with all of the flowery language. Produced, consumed, needed, da-da-da. What are you given? And put that over 1. What are you looking for? That is the unit you need in the numerator in the end.